Hello viewers, in today's session we are going to discuss another important problem from derivatives, and here we are going to differentiate this function f of x which is equal to sine inverse, and here we have square root of 1 plus x raised to n plus square root of 1 minus x raised to n divided by 2, right? So here we have to find out the derivative of f of x with respect to x. Now here to get the derivative of f of x, we'll make use of the method of substitution to simplify this function by introducing another variable, right? So let us start. So here let us substitute this term, that is x raised to n equal to cosine of theta, right? So we'll make this substitution to simplify this expression, and x raised to n is equal to cosine theta. So now this function f of x is now equal to sine inverse, and here we have square root of 1 plus x raised to n. X raised to n can be replaced by cosine theta. Then here we have 1 minus cos theta. Again x raised to n is replaced by cosine theta, and here we have 2, right? So now here we'll make use of some trigonometry, and from trigonometry we know that 1 plus cosine theta is equal to 2 times cos square theta over 2, and similarly 1 minus cosine theta is equal to 2 times sine square theta over 2. So these are the two important half angle formulas. So here we have now sine inverse and square root of 1 plus cosine theta, and 1 plus cos theta is replaced by 2 cos square theta over 2, and here we have square root of 2 sine square theta over 2. So replacing 1 minus cosine theta by 2 sine square theta over 2, and in the denominator we have 2. So now we can write sine inverse, and here we have square root of 2 and cos square theta by 2. It can be taken outside the square root sign, so we have simply cosine theta by 2. So this square get cancelled with this square root, and similar is the case here. We have square root of 2 and sine theta over 2 divided by 2, right? Okay, so now let us take this term as square root of 2 over 2 cosine theta over 2, that is distributing this 2 over this term and this term, so that we can write this entire term as a sum of two expressions. So the first one is the square root of 2 over 2 cos theta over 2. Then we have square root of 2 over 2 sine theta over 2. Right? Now square root of 2 over 2 is equal to 1 over square root of 2. So now we have sine inverse, and here we have 1 over square root of 2 cos theta over 2 plus 1 over square root of 2 sine theta over 2. So now let us replace this term, that is 1 over square root of 2 by sine pi by 4, because sine 45 degrees is 1 over square root of 2, and this term can be replaced by cosine pi by 4, that is 1 over square root of 2, right? So now we can write sine inverse, and 1 over square root of 2 is sine pi by 4, and here we have cos theta over 2, and then 1 over square root of 2 can be written as cos pi by 4. Here we have sine theta over 2, right? So now we have this expression in which we can assume pi by 4 as alpha. So alpha is pi by 4, and beta can be taken as theta over 2. So we have sine alpha cosine beta plus here we have cosine alpha, and then we have sine beta, right? So this is the well-known sum formula, angle sum formula for sine function. So we have sine of alpha plus beta, right? So sine pi by 4 cos theta by 2 plus cos pi by 4 sine theta by 2 is equal to sine alpha plus beta, where alpha is pi by 4, beta is theta by 2. So we have sine pi by 4 plus theta by 2, right? So now this expression is equal to sine inverse, and here we have sine pi by 4 plus theta by 2, right? So this expression is equal to sine pi by 4 plus theta by 2. So here we have sine inverse sine pi by 4 plus theta by 2. So now these two get cancelled, or from inverse trigonometric functions we can use the concept of principal value branch. So we have these two get cancelled. So we have pi by 4 plus theta by 2, right? So now our function f of x is equal to pi by 4 plus theta by 2. So f of x is now equal to pi by 4 plus theta over 2, right? Now let us replace this theta by cos inverse x raised to n, because when x raised to n is equal to cosine theta, then theta is equal to cos inverse x raised to n. So let us replace this theta by this expression over here. So we have f of x is pi by 4 plus half cosine inverse x raised to n, right? So this is the simplified form of this expression using this substitution. So now we have to find out the derivative of f of x with respect to x. So let us differentiate f of x with respect to x. So we have d by dx of pi by 4 plus half cos inverse x raised to n. Now pi by 4 is a constant, and the derivative of a constant is 0. So now we have simply d by dx of half cos inverse x raised to n. Taking half outside this operator, we have d by dx of cos inverse x raised to n, right? So now we have to find the derivative of cosine inverse x raised to n. So here I will make use of this result, that is the derivative of cos inverse theta is minus 1 over square root of 1 minus theta square, right? So here for theta we can take x raised to n. So we have half, then we have minus 1 over square root of 1 minus theta square. Theta is x raised to n square, and then by chain rule we have to find the derivative of x raised to n. So now simplifying this, we have minus 1 over 2 times square root of 1 minus x raised to 2n, and then the derivative of x raised to n with respect to x is nx n minus 1, right? So we can write now minus n x raised to n minus 1 over 2 times square root of 1 minus x raised to 2n. So this is the derivative of f of x, where this f of x is equal to this function, and the derivative is given by this expression. So let us discuss one special case here. Suppose we have n is equal to say 4, right? So when n is equal to 4, then the function f of x, it assumes the form sine inverse square root of 1 plus x raised to 4 plus square root of 1 minus x raised to 4 over 2, right? And the derivative of this function f of x, that is f prime of x, is given by substituting n is equal to 4 in this expression. So we have minus 4, then we have x raised to 4 minus 1, then we have 2 times the square root of 1 minus x raised to 2 times 4. So here we have 2 times 2, 4. So this is minus 2 x raised to 3, and here we have square root of 1 minus x raised to 8. So 2 times 4 is 8. So the derivative of this function f of x when n is equal to 4 is minus 2x cube divided by square root of 1 minus x raised to 8. And similarly we can discuss other cases also.